Good afternoon to everyone. I'm here to present the work done by Luz-Angelica Rodriguez, Diana Tirado, Omar Parra, and Enrique Estupiñán, who is speaking. This work is inspired in a master thesis of the Colombian School of Engineering, and it is called Attraction-Repulsion Function for Modeling Bicycle Use in Bogota. Like many cities, big cities, there is a lot of problems in the mobility of the city. We are the fifth most congested area in the world. We have a long time to commute. It is more than 1 hour and a half, and it is estimated that it costs us like 2% of our GDP. We are ranked 166 in the driver satisfaction in Waze rank. On the other hand, the bicycle is perceived as a good, excellent means for transportation by 62% of the people. We are ranked 12 in the Copenhagen Index, and we have the largest number in Latin America of bicycle trips. So this is a big opportunity to understand how to make it better. So we study by a survey what are the factors that influence the decision to use the bicycle, from saving money, the environmental considerations, geographical conditions, for example, if it's hilly or it's not hilly, the culture, the distance that you need to travel, the economic change that is involved, the incidents, and by incidents we mean small accidents in the road, the infrastructure that you have not to compete with the cars, with the buses, the installations like parking places, like places where you can connect to the buses. Also, we consider the health association with the performing exercise by using the bicycle, the safety of the roads, and the time consuming for doing the traveling. After the review of the survey, we found that the most important characteristic is the safety, the second one is the time, and the third one in Bogota is the health. So we decided to make a model. In the model, we have the attractiveness of the cycling, and we have many loops. In one of the most important loops, we found that as bicycle users increases, then the other uses of transportation reduces, and the incidents, if there are incidents, those reduces the attractiveness of the cycling. Other loop means that if there is more bicycle users, then there will be more public policy in order to make safety the roads on the use of the bicycle. And of course, if there are the perception that the bicycle use is more friendly with the environment, then that reduces the uses of other transportation means. And additionally, we have this other loop that we see that we require more infrastructure and more, it reduces time, and it makes it probably more interesting to use the bicycle. We have another variables like health and personal care, environmental conditions that affects the use of the bicycle. We use a model, a function inspired by the robot behavior, like we need to have these robots cooperating, working together. So if they are far apart, they are pulled around the group, and if they are too close, so they are pulled off far away. So the position that it is going to be used is in the middle, where they can work together and get better results. We implement that in our model, and the model shows that, for example, in the 20 month to the 40 month, then there is an increase in the use of the bicycle because some of this attraction to the use of the bicycles. But from the 40 to the 60, we see that, especially for the rainy season, it is reduce the use of the bicycle. And afterwards, then we see a big increment because the perception of the environmental friendly within the users make it much better. So we need to consider the safety, the environment, the healthcare, the time, the distance, the installation, the culture, and the economic factor as something that attracts to the use, and the climate conditions and incidents and infrastructure, something that makes not appealing the use of the bicycle. If you have any questions, if you have any comments, we will be pleased to answer and to hear them. Thank you very much.